We're also going to show a classic set of tests carried out by Dudley Thompson with the Rover Saloon, demonstrating the importance of suspension design.
Well, that was a much rougher road than you would normally expect to have to drive over. In fact, that track was part of a proving ground designed to push car suspensions to the limit. And yet it was still a pretty smooth, comfortable ride, the result of years of development. People probably first started to think about isolating their passengers from the road in the days of the stagecoach. We've come a long way from the simple cart spring to the complex arrangement of links, springs and dampers that go to make up a modern car suspension. This programme's about vibration isolation, the sort of thing that we take for granted with a modern car. But take a look at this. In this car, we've modified the suspension. The characteristics aren't quite right. And watch what happens when we take this one down the track. Can we use the idea of a mass spring damper model to help us understand the difference between those two suspension systems? Well, firstly, we need some way of actually measuring the characteristics of the two suspensions. Well, motor manufacturers use rigs like these to study vibration isolation. Road profiles are stored on magnetic tape, and the tape then used to control a flow of high-pressure oil to these actuators. Vibration isolation is about the amount of motion we get at the body compared with the motion we get at the road. These transducers provide us with signals which are proportional to those displacements. So during testing, we can get a measurement of the relative motion of the two. And we can look at the output from those transducers on an oscilloscope. This is the car that didn't perform so well on the track. And we can see the displacement time curve for the car body on the oscilloscope. So that shows the characteristics of the modified car suspension. What happens if we perform the same sort of experiment on the unmodified car? The oscillations die away very quickly. I'll do that again, and this time, look at it on the scope. So how does that compare with the trace we took from the other car? This is the trace we took from the first car. That's the one that didn't perform so well on the track. You can see that the amplitude dies away over about 10 oscillations. In the second car, this is the one that performed well, the oscillation has died away almost immediately. So in fact, the difference between the two suspensions is the degree of damping. The one that handled well is more heavily damped.